So this is my vending machine controller implemented on the board. So as you can see, by default, there's a balance of 0, which is indicated by the B here. And then if I wanted to load a balance, I would use these 4 switches. So for example, I could give a balance of 1 or a balance of 4. And then the items are represented by these buttons. So item 1 costs $2, item 2 costs $3, and item 3 costs $5. So if I try to buy item 3 here, it will give me an error message because the cost is greater than the balance. However, if I try to buy item 1, which costs $2, it will give me a change of $2 because 4 minus 2 equals 2. And here's the code for the project. So the first module is mux 4-bit 4-to-1, and what this does is it loads in the 3 costs for all 3 of the items, as well as 0 by default if no buttons are pressed, and outputs the costs. So in this way, each button represents 1 cost. The next up is mux 4-bit 2-to-1. So what this does is it chooses whether to display the original balance if the balance was too low for the purchase, or the change if the balance was high enough. So it takes GT, which is the output of the comparator, as its input, and then chooses between change and previous balance based off of that, and puts that into out. It also outputs a state register, and what that does is determines what to display onto the 7-segment display. The next up is subtractor 4-bit, which is pretty simple. It takes a balance and item cost and outputs a change, which is balance minus item cost. And so this is one of my 7-segment decoders, which I called state decoder. So it has 3 cases, and we'll set the display to C, E, or B, depending on what state is inputted. And this is the other 7-segment decoder, which takes input X, which is the balance or the change, and displays the number that X represents. So this is my implementation of a comparator 4-bit structurally. So this is pretty complex, but basically what it does is it takes the 4 cases that must be true for A to be greater than B and combines them into a big OR gate. So what those cases are is whether the leftmost bit of A is 1 and the leftmost bit of B is 0, or if the leftmost bit of A equals the leftmost bit of B and A sub 2 is 1 and B sub 2 is 0, or if the leftmost bits of A3 and B3 and A2 and B2 are equal, and A1 equals 1 and B not B1, which is B1 equals 0, and so on. So basically it takes all 4 of these cases and combines them into this final OR block here, and what that does is output GT, which shows whether A is greater than B. Hopefully that makes sense. And this was an old structural data flow implementation of the comparator, which is comped out. So finally here we have the final vending machine, which is a structural implementation of this schematic right here. So here I have added my mux, my comparator, my subtractor, my other mux, and then my 2 7-segment decoders. And by connecting them like this, the final vending machine is achieved.